Hello, everybody. This is George Anastasopoulos, and I am back with you in a new presentation about risk management for conformity assessment bodies. Today, we'll have the opportunity to explore a practical example of implementation of a risk management approach that it can be used by different conformity assessment bodies, laboratories, testing, calibration, medical, inspection agencies, product certification bodies, and personnel certification bodies. So let's start our presentation for today. A few words about our organization first. We are Perry Johnson Laboratory Accreditation, an accreditation body established in the United States in 1999. We're headquartered in Troy, Michigan, and we have provided our services to more than 2,100 accreditations in different sectors in 32 countries. In addition to our organization, we are in the same group with the non-profit pjlabs accreditation body that it can be used also for specific applications. PJLA is operating a global network, and we provide our accreditations all over the world on many different programs. So you can see here many different programs. It's also not a coincidence that those programs are accreditations that you can utilize the information I'm going to provide you today about risk analysis. So we are accrediting testing and calibration laboratories to ISO 17025, medical laboratories to ISO 15189, and inspection bodies to ISO IC 17020, product certification to 17065, proficiency testing providers 17043, reference materials producers 17034, personnel certification bodies 17024, and special accreditation for training providers of certificate programs only to ASTM E2659. PGLA is recognized by many regulators, associations, and international and national entities. I'm not going to go through all of them, but the most popular and the organizations you may are aware of are FCC, Federal Communication Commission, CPA, the US Environmental Protection Agency, FDA, and so on. Many approvals and recognitions by many regulations in the United States and all over the world. Also, PGLA is a signatory of the APAC and ILAC MLAs, and also we are a member of the North American Accreditation Forum. So let's proceed to our topic for today's risk assessment, risk analysis. And I would like to emphasize on that element because it is one of the important critical elements in conformity assessment body accreditation. So risk assessment and a risk thinking approach are both key aspects in conformity assessment. And accreditation bodies all over the world, they must consider the impact of risk on all the activities of conformity assessment bodies on an ongoing basis. This is the terminology used in the standards. Why do we need risk assessment? Risk assessment is used to ensure a consistent data-based approach for conformity assessment bodies. And you will be surprised to see that risk requirement is everywhere on the accreditation standards. For example, on 17025, which is the accreditation standard for testing and calibration laboratory, you will find 31 references to risk. On 70021, which for management system bodies, 26 times. Even the general standard 17011 that sets requirements for us, the accreditation bodies, we have 21 references to risk evaluation. And what is the requirement in all this standard that we should have not only as an accreditation body, but you as a conformity assessment body? We should have a process to identify, analyze, evaluate, treat, monitor, and document on ongoing basis the risks to impartiality arising from our activities. But is it only impartiality? Not, of course, because all these 31 or 26 references are not coming from the impartiality clause. They are coming all over the standard. So risk-based thinking is not only limited to impartiality considerations, it is extending to all standard or most standard requirements. So implement a risk analysis to identify the risk to related conformity assessment body activities is the main requirement. And how we do that? Today, I'm not going to describe you the standard requirements. I would like to give you an approach, a specific approach that you can utilize to implement a risk analysis. The logic is the following. First, we have to address the applicable management system requirements that, yes, we should know what are the requirements of each applicable standard to our conformity assessment body, and then we should detect areas of risk. We have to perform a risk analysis, whatever risk analysis methodology we may choose. I'm going to propose you one today. We have to develop contingency plans, and also we have to develop mitigation plans. So this is a complete approach. Now be careful. What I'm going to tell you today, the advice I'm going to provide you today is not limited only to the standard requirements. It means that the risk approach I'm going to present you can be extended to any different processes in an organization. So even if you want to address risks that are not related directly to the standard requirements, you are free to do so. Personally, I am suggesting that when you are implementing the risk analysis, you are not only limited to the standard requirements. Why? Because if something happens, if a risk evolves to a crisis, the consequences to the company will be there independently if they are required or not from the management system standard. So if you can resolve risks, if you can develop contingency plans and mitigation plans for all the risks that your organization can face, it is good for you. It is to your benefit after all. Now, when you're going to develop your technique, I'm suggesting you to prepare to use some metrics. So you have to identify the number of the total staff that it will be involved. So you may ask me, it's not just a business of the quality manager or whoever you're going to call, however you're going to call the person responsible for this. No, the risk analysis is something that most of the part of the organization, at least the management part of the organization, should be involved. And why is it so? Because the risks can be identified of different areas or processes in the organization. So the people who are performing those processes, they can easier identify the potential risks. That's why we need to involve different people. The second important is that how many rounds is the staff going to be involved? In the methodology I'm going to present you, you will see that there are 2 to 3 rounds that the staff is involved. And then you may ask me, okay, and what is the expected total risk, the number of the risks to be identified? There are no answer to that. Depending on your company, the complexity of your processes, and the size of your company, you may have identified tens, even hundreds of risks. And so we have so many risks, and we are not aware of that. Maybe you are aware of some risks, but you are not, if you are not following a systematic approach to identify them, you will never be aware of how many total risks you may have. Of course, on the next point, you will see group the risks. And I say group the risks because sometimes different people may consider risks with different names, but actually it's the same thing. So when you identify the risks, and I will show you how to do it later on, the responsibility of the team that's going to working on the risk analysis is to group the risks of similar wording. So not repeat the same risk with different words. In this way also, we will reduce the number of the risks and it will be easier to handle them. And of course, you have to check number of actions to be considered for contingency plan, number of actions to be considered for mitigation plan, and what will be the time period that you will deploy this project. Okay, many things say, okay, we're gonna do it, it will take us a few days, 1, 2 weeks. Okay, you can do that, depending on the methodology and the people involved. The methodology I'm gonna present you that it is involving many different people for many different processes in organization. It typically takes months. And the reason it takes months is because you need time for the analysis and the implementation of the methodology that I can say it can be done in 1 month. Then perform the actual risk process, risk analysis process that it can be 2-3 months, and then process the results and prepare the reports and identify contingency and mitigation plans that it will be another few months. You say, why it's so long? Is it so complex? Not really. It can be done much faster. The reason that it takes long is because in most of the companies, in most of the conformity assessment bodies, it's not the only thing we are doing. We have many more responsibilities. We are performing many more tasks. So risk analysis is one of the elements we have to do, but also we are going to do more things. So that's something that we have to consider. Anyway, I don't know if it's going to be 6 months for you. It can be 2 or 3 months or 1 month, but still you have to define and see how long it's going to take. I also mentioned before grouping of risks. And I told you that because you may have many risks, it is good to group them. If you can group them, then you reduce the number of risks per category. So it is easier to handle them, and it is easier to present the results of your analysis. Are there any standardized categories? Not really. These categories I'm going to present you are just categories based on experience, practical categories that they can be addressed in a conformity assessment body. But of course, you are free to group your risks according to your experience, according to your specific needs in your company. So in the risk analysis I used to perform, I like to group my risks in a first group that's general financial and administrative risks. So it is obvious what are the risks about. Risks related to business operations, markets, and the context of the company. For example, if your company, your conformity assessment body is operating in different economies, different countries, and so on, probably risks can be introduced from this different countries. So you have to group all the risks, the international, let's say, related risks in this group. Risks related to IT systems, because everybody is using IT technology nowadays. We are using data acquisitioning systems, data processing systems. We are using even simple computers that we are going to save the data of our tests, data of our inspections and so on, data of our clients, data of specimens, many different IT systems involved, reporting and so on. So many risks can be related to IT technologies you are implemented. Okay, the core of risks that it is related to the conformity assessment body's main processes, like testing, inspection, certification. So they are the main risks. When you study the standards of the ISO 17000 series, most of the risks and the reference to the risks on those standards are related either to impartiality or those specific process-related risks. But as you can see, I am presenting you different groups that they will cover all the entity, all your organizational processes. That's why I am introducing many more groups of risks. Then risks related to management system policies, procedures, and processes, and risks related to conflicts of interest and impartiality, which is one of the main requirements, as we already mentioned, of the standards. And then I have another 7th group, risks you cannot categorize, you cannot associate with one of the previous 6 categories. You can include them on the miscellaneous risks category. So I repeat once again, it's not that you should have those risks. It's not a requirement. It's just a good suggested practice you could follow. In general, such grouping is going to help you on following up a large amount of risks, plus also is going to help you presenting that to your top management, and it is easier for top management to handle the risks in groups related to different processes. Now, it's the moment that I will present you the actual risk analysis methodology. One more point I would like to mention here is that this methodology is not a requirement of a standard. So the standards, the ISO standards related to management systems, and many of them are the conformity assessment related standards, do not specify any specific risk analysis model that you should follow. So it is your decision what kind of risk analysis you will follow, but I want to give you an example. So I'm going to give you an example, which is called modified risk think approach. Think is a guru in crisis management, and this methodology of risk analysis approach is proposed by Stephen Fink, which is a simple method, but it is so simple, and in the same time, it can also be quantified. So it helps you to repeat it in different cycles. I will come to later to that. So it's a very simple methodology. You don't need to have special knowledge or be aware of complex mathematical models on how to implement this methodology. And many different people of your organization can be involved in the process and can easily understand the process. So the first important step is that you should seek input from personnel in your body, that they will ascertain the top risks are perceived by different groups of people on different departments. As I told you, the risk methodology, the think approach, is not a methodology that is limited on 2 or 3 experts in the company, but it is a methodology that is expecting the involvement of at least senior management or main and middle management on different departments. Then the risk will be divided in the broad categories I did mention in the previous PowerPoint, and then the risk will be combined to bring the overall list in a more manageable level. So, in the next step number 4, you should ask your staff and the individuals you are involved in the risk analysis about 2 elements: the likelihood of the risk materialization and the impact that this risk will have in your company if it will materialize, evolve in a crisis. Now, if you notice here, there is a reference to staff and all individuals, and you may ask me, okay, it's not only the staff, who else can be involved? For example, many organizations understand the staff as their full-time employees. If you are a certification body, for example, you can also include on your risk analysis some senior auditors you are using. So it is a good input to get from people who are part-time involved in your processes, but sometimes they are very critical on the operation of your organization. So if you are a product, for example, certification body, and you are using many experts, technical experts, contracted auditors, these people are very important because they come in direct contact with the clients and they get input from the market. So selecting some senior of those individuals and involvement in the analysis, in your risk analysis, can be very useful. If you are a testing laboratory, probably you can be limited only to the internal staff. Anyway, and then you are going to calculate a value. I'm going to show you how you do that. That it is called, if you know the likelihood and the impact, it's called CIV. In the think method, CIV means crisis impact value, and it is calculated for its risks. And the risks then are ordered according to crisis impact value to largest, from largest to smallest. I'm going to show you in graphics how you're going to do it now. So don't be confused. So two elements. The first is the probability factor, is when you ask your staff how probable is for a risk to materialize, to evolve in a crisis. And then the second question is how important, what will be the impact if that risk materializes in a crisis. This is the crisis impact value. So as I told you in my previous PowerPoint, the scales are 0 to 100 for the probability. So 0 means not likely to happen. 100% means extremely likely. It is happening any moment now. And the impact is from 0 to 10. As you can see, 10 is very important impact. 0 means insignificant in reality. We don't care. So those two are the two factors, the two elements that we will ask our people to identify. But then you're going to ask me, they will identify probability and impact on what risks? How do we know what are these risks? And here is a very good question. Before we starting quantifying our risks, we have to identify them first. So how we identify them? I told you before, but I want to repeat them. The first is existing risks that happen in the past, problems. And we had probably crisis in the company. So you have to use your previous experience. The second source is risks that from bibliography. You can search papers, there are publications from similar organizations related to conformity assessment that they are presenting their experience and their finding from their risk analysis. The third category is the most popular for me, the most useful also is brainstorming. So group your people. All these people that are going to be involved in the risk analysis, group them and perform brainstorming sessions. So ask them directly, what are the risks you believe that they are involved in your company? And the people, you will be amazed to see that people from different departments, they will give you totally different risks. For people from the financial department or accounting, they will give you risks related to the financial status of the company. So we run out of resources, or we don't have appropriate credit, bank credit. And you will see other risks related to technical issues that we don't have calibrated instruments, we are not confident about the test results, potential mistakes or errors on the instrument measurement, or lack of consumables or whatever. So each person, based on their own experience, they will provide you potential risks. So previous problems, previous risks that evolved to crisis, number one. Then bibliography, number two. Third and most important, ask your people, listen to your people. They are the best source to identify risks. Then you prepare the list of risks, and then you ask them, you go back, asking them what is the likelihood of each of those risks to materialize and what will be the impact. The moment you have identified those two numbers, then you can place a dot on your graph, probability versus impact is your graph, and then show its risk. So one risk, for example, according to your analysis, has a 70% probability to happen, but impact only one. It can be, for example, this point, the point I'm showing you right now with my cursor is point number one. Another risk that it has probability 20% to happen, and it has an impact value of 5, it can be risk number 2. So if I know the probability and I know the impact, it is very easy to locate each risk on my graph. Now, if somebody is asking you, which is more critical risk, number 1 or number 2? If I have limited resources and I can address only one risk, which risk I may choose, number 1 or number 2? So in order to help yourself to categorize the risks, we have prepared this graph on the right-hand side, and you see different zones. So top right are the high-risk zones, low left are the low-risk zones. And in the middle, we have two middle risk zones, one the middle to high and one the middle to low risk zones. These lines here, these curves, are curves that are calculated mathematically to have the same risk level. It means that multiplying probability versus impact is going to give you the same number. So not by coincidence, if you look on the chart on the left-hand side, risks number 1 and risk number 2, as you see, they are on the same exactly line. So this means that those two risks are of the same criticality, because if you multiply probability times impact, you will get the same result. Now, you're going to say, if I have 100 risks, can I handle all of them? Do I have resources to work on all of them? So many of the companies say that risks falling within the medium to high risks level then can be isolated, and higher can be isolated and work. So many companies say, okay, if I have many risks on high risk zone and middle to high zone, then those are the risks I'm going to prioritize. give priority to them. Now, if I don't have risks on the high risk, just a few in the middle and the many on the middle low, I'm going to work also with risks on the middle low. So in general, we are setting our priorities from top right to left low. I understand that this depends in every situation, in every company, it will be different. So when you will perform your analysis, you will categorize your risks, and then you will choose what priorities to set, to give. So when we plot each risk on those graphs, so we know which risks are high risk zone, which risks are middle and middle low and low risk. We are starting the next step, which is developing mitigation plans. Again, you will start working on the mitigation plans and your contingency plans always from the high risk zone going towards the low risk zone. Because you may have, again, I repeat, limited resources, and you may not be in position to adequately address all your risks if you have tenths of risks. So what is a mitigation plan and what is a contingency plan? And what is their difference? So mitigation plan is enacted to reduce the likelihood and or impact of a specific risk. So we have to take actions that they will reduce the likelihood and or impact of a specific risk. And you may ask me, why don't reduce both of them? Because sometimes it is not possible to reduce both of them. So for example, if you have a sensitive risk related to earthquake, let's say, can you reduce the likelihood of the earthquake? Not really, because you don't decide when an earthquake will happen, but you can reduce the impact. Okay. There are other risks, though, that you can lack of resources, for example, or lack of testing material, and so on. You can reduce both of them. Contingency plan now. What is contingency plan? Is respond to a crisis arising due to a specific risk. Now, if although we in the mitigation plan we tried to reduce the likelihood and or the impact of the risk, still, if a risk involves in a crisis, what is our plan? How are we gonna respond to that? So in this case, you need to be prepared. Be prepared is very important. Contingency plan is also as equally important as mitigation plans. Because people in general, sometimes they don't know what to do, how to react, and the crisis is evolving and nobody is there to stop it. So in order to conclude on those two important elements, the mitigation plan and the contingency plan, I would like to say that remember and interrelate mitigation plan as something synonymous to preventive actions related to risks, and contingency plan something related to corrective actions related to risks that evolve to crisis. Okay, so in general, I just want to remember that a risk as a risk is not risky, it's not dangerous. Okay, the problem is when a risk is evolving to a crisis. So what we want, and we should not worry if we identify many risks. The problem is if these risks are evolving in crisis. So it is very important that we can identify as many as possible risks. And then we are going to work to prepare mitigation plans. We're going to work to prepare contingency plans so we are ready to handle, to manage a crisis if those risks or one of those risks is evolving in the crisis. That's why in reality, in many cases, we say that the risk analysis that we are performing here is under a wider plan, that it is called a crisis management plan. So a crisis management plan includes the risk analysis, includes mitigation plans, includes contingency plans, but also it includes some additional elements that I'm not going to present on this presentation, like, for example, communication plans and so on, that are not related directly to the risk analysis and risk management. They are elements of the crisis management. So, when the risks are categorized per calculated CIVs and in all different groups, what do? We present our presentation per group. You remember a few minutes ago, I present you these 7 different categories of grouping the risks. Now, the graphs I did show you will be completed per category. So that's one example. So we're talking about the process risks, process-related risk, which is the fourth category of a testing laboratory. So this is an example how the results of your risk analysis will look like. So if you just give the mathematical results to your management, they will be confused. But if you present it on such a beautiful chart, it will be very easy to understand what is going on. So if you have those 7 groups of risks that I presented you before, I am expecting to see in your presentation 7 such graphs. I'm not going to show you now 7 different graphs. Our time is limited, but I'm going you to show this one, which is the most important, the main process related risks of a testing laboratory. So during the risk identification, the staff and also my search in papers and my search in previous problems identified me many different risks. On the table to the left, you can see some of those risks related to process. Some of those risks are, for example, limited personnel during peak season. Technicians are not trained for rare tests. Rare tests are tests that are not performed very often. A risk was identified to be the non-calibrated instrumentation, or we forgot to do the calibration. Another risk was related to limited availability of proficiency or in the laboratory tests. Another risk was related to lack of consumables, inconsistent results due to testing signal interference in the signal processing process, misaligned test machines for this specific lab, that could be a risk, discounting prices affecting perceived value of testing, inconsistent billing process. Here I added, to be sincere, some other risks related to main processes of a lab, but not only the testing. I would like to show you also some risks that are not directly technical, but they can be also related to other processes, like inconsistent billing process, misplaced specimens, specimens not provided in time by customer, or errors in sampling. So for that lab, those are the identified risks. They did perform the probability and the impact analysis. They calculated the probability factor and the CIV factor, and then when we did the graph, we see all these risks that they are placed on our graph. So it is very easy to understand if I'm the management and I'm going to ask you, what are the 5 top risks that I have to work first and assign resources? The answer is very easy. We go here, there's no risk on the top. We have a few risks on the middle to high zone. So risk 8, 11, 9, 13, and 6 are the first 5 risks I have to work with. If I want to add 3 more, I will go to 12, 7, 5, and then and so on. So this is a very good way to present and have a very nice understanding of the process. Now, this next step is very important and will show you how useful and how easy is to handle the think method. The risk analysis is not only one-off process. It's not something that we will do today and we will forget about it. It is an ongoing process. The standards 17,021, 17,020, 25, 24, they all say that you have to perform your risk analysis on an ongoing basis. Of course, they don't say you every 6 months or every 2 months and so on. But here, I'm showing you the same analysis that is performed in that lab after 2 years. So what they did initially, they did start with the first analysis that it was performed in 2022, and they, in between they did more analysis, and the last round of risk analysis were performed on 2024. And you see here with black the numbers they got in 2022 and the numbers in blue that they get now. And with these small nice arrows, dotted arrows, you see how its risk is changing location. For example, risk number 11, non-calibrated instrumentation. In 2022, it was considered during the analysis from the staff as a low risk. Why? Because at that time, they had a very good program of risk, of calibrations. And then they didn't apply the same attention, they didn't provide the appropriate resources, and now in our 2024 analysis, we see that risk 11 jumped to middle to high risk zone. This means that our company did not take the appropriate actions to reduce the level of the risks, and to the contrary, for me, that I am an experienced risk analysis expert, this graph shows me that the company did not pay attention at all to their system, to their management system, to their technical issues, and the whole situation is worsened. Because you see all the risks are moving, most of them are moving either right or right and up, which means that the risks are becoming worse, the situation. What we are expected to see, exactly we are expecting to see the opposite direction. We would like to perform the risk analysis, then proceed in actions, assign resources, train our people, and when we will repeat the same process after 6 months, 1 year, 2 years, we will see that our risks are moving lower and left, not like this graph. So only from such a short view of this beautiful graph, I can easily understand what is going on in the company. And if I'm the management, I'm going to worry. And I'm going to emphasize much more seriously on how to handle my risks. So the beautiful thing with this think method is not only that you can quantify your risks in an easy way, but also you can see how they move in the time. And during that movement, you can see if you are improving, or if you remain stable, constant, or you are going back. So this is a beautiful tool. And really, I see many companies where conformity assessment bodies that they are implementing it, that they are very happy, and it is very easy to perform and very easy to present and understand the results. Now, as part of our analysis, I would like also to show you a small example of how this mitigation plan or contingency plan may look like. So on the first column, I have the risk, main process, testing laboratory, limited personnel during peak season. So what we can do as a mitigation plan, cross-training of staff. So because we have limited personnel, it does not mean that we have to hire people, because it is only during peak season. What are we going to do? Of course, we can hire seasonal technicians, but in many labs, it is difficult to find seasonal, experienced, competent staff. So what we do cross-training of staff. So if we have a peak on specific test, then we can utilize technicians from another category of tests to help us. Now, what will be the contingency if still this is not enough and these risks evolve in crisis? We have so many tests, orders of tests coming in, and for all, let's say, for all different categories. So we don't have appropriate people. The contingency plan should say that we should be ready to subcontract tests. So we may have to, in the time that there is no problem, find out other labs, possibly competitors, that they have the capacity to perform competent tests and have agreements with them, and they can help during the peak season and have agreements to do that and so on. So I don't say that this is the appropriate contingency plan for you. I'm just giving you some examples. I just want you to understand the difference between mitigation and contingency plan, okay? So there are more examples. I don't unfortunately have time to read all of them. Let's try one more. The last one. Let's see the last one. It says the risk is in the testing laboratory area again, misaligned testing machines. Here we're talking about, for example, universal testing machines that were performing a tension test on, let's say, plastic or metallic specimen. One risk is there that if the grips are misaligned, we are not going to get correct results, because we don't apply only tension, we may apply different forces, and will be out of control. So what is the mitigation plan? The mitigation plan is update our preventive maintenance programs. So we are frequently checking the alignment of our grips in our testing machines, perform internal controls before each test. So don't worry for the, I don't know, annual or 6-month calibration, because when I have the calibration of the testing machine, they do check it. But in between, grips can be misaligned again and again. I cannot wait for the next calibration round, but I have to train my people to perform internal controls of misalignment before it's tested. So I am sure this way that this risk will never evolve to a crisis. I'm going to be sure that every day I'm going to do my tests with aligned grips. So this is my simple mitigation plan that involves training, plus also may involve having some small, simple instrumentation to perform this task. Now, what is the contingency plan? Utilize alternative testing machines. So if I see that still the problem is there, I should have also probably an alternate testing machine that I can utilize if I check and see that my grips remain misaligned. That's an approach. You may have something else in your mind, or it change grips or whatever. So depending on the technical expertise of your staff, you will decide the appropriate mitigation plans and the appropriate contingency plans. One point I would like to emphasize is that many conformity assessment bodies, management of conformity assessment bodies, during assessments I did as accreditation body, they told me, oh, you know, Dr. George, all these things require money, require resources, and we're very tight. And all these things is just a requirement of your accreditation body, and we just want to be accredited, and we cannot spend all these resources. This is a wrong approach, ladies and gentlemen. You don't do your risk analysis for the accreditation body. You don't do it because it's a requirement of the 17025 or 17021 standard. You do it for your own good. And if you're the management, allow me to say you're doing also for your own profit. Because if you allow your risks, first, if you don't know your risks, you will definitely go to get crisis. Even if you know your risks and you don't perform mitigation plans and you get crisis, this is cost for you. And this is lost man hours, it can be lost equipment, it can be lost clients. So my suggestion is that your accreditation body requirement should be the last one. Your first priority should always be your well-being as a laboratory, your well-being as a company, as an organization, financially, I mean, and also the well-being of your people from the point of view of safety, because many risks can be related to safety. I remember I was assessing once a lab, and I could see that they are connecting their testing machines with non-grounded sockets, and there was no grounding there. And say, first, you have two risks here. The first risk is that if you have no grounding, your signal analysis can be wrong because there is a noise that it is introduced on the signal analysis, so you may get wrong results. The second thing, though, it is you may have also problem with safety, electrical safety issue. So a risk analysis should identify that, and the mitigation plan should be, of course, to introduce the appropriate sockets, grounding, and so on. So you don't have to wait to have an accident, don't have to wait to get wrong results, have litigation issues, or lose clients. So the risk analysis is a tool for your improvement, is a tool for your safety, is a tool for your financial success, and you don't want to have risks evolving in crisis. So the more and the better risk analysis you do, and the more risk you identify, the more opportunities to resolve them in advance. That's why I am insisting that the risk analysis is not something that you have to perform seriously because accreditation body is asking for it. Because I go to many labs and they give me a page of paper and say, this is our risk analysis. Okay, it is, to tell you the truth, guys, a junk risk analysis, which is in reality complies with the theory of the standard. I cannot issue non-conformity, but in reality it's a risk analysis which is really useless for the conformity assessment body. It will not prevent any real risk, and it will not save them money and will not increase their competitiveness in the long race. So my suggestion is that when you do something, do it seriously. And one of these actions that really will help your organization, risk management, risk analysis. So learn how to do it and do it in a way that it is efficient for your conformity assessment body. I don't say to follow my method. It's not my method, it's Fink method anyway. But open the books or access internet and you can find many nice risk analysis methods that they are simple and efficient and effective, most of all. So do it in a right way. And we are here, although as an accreditation body, we cannot offer consulting. We are allowed to organize trainings. We have trainings like this one in risk management. We can do detailed trainings on risk management and crisis management, introduce you in this wonderful world of how to prevent risks to evolve in crisis and how to save money and how to save accidents, reduce the accidents and so on. So we are here to support you in the way that it is allowed without having also conflict of interest with our accreditation responsibilities, but still it is your understanding that it will help you to introduce and perform a really effective risk analysis process. So as I can see, I'm done, my time is over, but I would like to reply to any questions, if there are any questions. So if there is any Arabic translation, unfortunately there is not. But it is not something complex, it is not something difficult, so it would be easy for you to develop such an Arabic version. I don't see any other questions here. Okay, still we have some time. If you have some questions about the model, we can use the questions field and I will be happy to reply. I see many people attending the presentation today. I also see many people, old friends and associates from different sectors, different companies, all over the world. So I would like to thank you for your participation. You can see my email on the screen. So this presentation will be uploaded by PGLA, so you can attend it again for free. Also, you can attend it with more staff from your company. So if you can go through again and again, you can see the methodology. You can use this methodology. If you have any more questions, even after the event, you have my email. You can contact me. You can email me your questions, okay? And I will be happy to reply and provide you any assistance I can provide. But I repeat, all the presentation with the PowerPoints will be uploaded in our PGLA website. This is information available to all of you. And I will be happy to see you implementing this methodology or something similar and improving your risk analysis approach. So as I don't see any more questions, I would like to thank you once again for your participation. And I will be happy to see you in one of our future PGLA online courses like this, or one of my future courses through PGLA that it will be announced soon through our website and our LinkedIn or other social media pages. Thank you and see you soon. Take care all over the world. Goodbye.